Another calculus example. This is exercise 4J from the book. I'll look at number 10. So it's got two parts, but at the very top, it says, consider the function, and it gives us this somewhat complicated function. So number 10, we have y equals the square root of x plus 1 times 3 minus x squared. Okay, part A. We want to show that the first derivative looks like this. So this means in this example, we're going to have to keep like expanding and factoring and rearranging until it looks exactly like we've got here. I feel like I've solved this before. Got it written somewhere, but I don't know where that is. So it's a show that, which means like I can't use what I'm I don't use the answer at the end. I just start working on what they asked and rearrange until I get there. So we should take the first derivative. But first of all, okay, I have a product rule, two things multiplied together, but then I also have this as a root. I would like it written with exponents. So let's rewrite this as y equals x plus 1 to the 1/2 times 3 minus x squared. So I have two different functions multiplied together. I will need the product rule. As I try to take the derivative of each piece of the product rule, I will need the chain rule, but I start with the product rule. So I have like this front one, I call u equals x plus 1 to the 1/2. I'm going to give myself a lot of space because I know I'll need it. And the second function, sliding way over, v equals 3 minus x squared. So for the product rule, I need to take the derivative of each of these with respect to x. Let's start with du. We want to get started and immediately we see, we need the chain rule because it's a composite function. So the inside, I already used u, I won't use it again. I got w. That's my inside function, which allows me to rewrite u as w to the power 1/2. I'm writing u in terms of w. So I take the derivative of each part. We have dw dx, which is just 1. And I have du w, which is 1/2 w, the negative 1/2, but I'll keep going to write it in terms of x. So going back to x plus 1, the power negative 1/2. For the u prime, the derivative of u with respect to x, I know that I'm being willy-nilly with my notation. I will typically only use Leibniz inside the chain rule. So I need to multiply this piece with this piece. Anything times 1 is just itself. That makes it 9. So this is 1 over 2 times the square root of x plus 1. Now coming over to v for the second part of my product rule. But again, I have a composite function. I've run out of colors up here. I mean, there's blue, but I need 2 colors, so I'll just repeat. So we have the inside function. I've already used u, v, w. X and y and z, we don't really want to use those unless we're literally talking about the x, y, and z axis. So I'm going to come back around to a. I'm calling this a, which allows me to rewrite v as a squared. Okay, I take the derivative of each of these with respect to the variable they're written in. So dA dx is negative 1. And dv dA is 2a, but I'd like that written in terms of x. So it's 2 times 3 minus x. I've done this problem before. I expanded it and then it ended up not being useful. So I'm actually going to leave this the way that it is, which gives us the derivative of v with respect to x. So v prime, it's going to be dv times dA dx, which will be negative 2 times 3 minus x. Again, I don't want to expand it because I already know the way the answer goes, and it's better if I don't. Like, we can see it when we're here. We know in the numerator we're going to need this 3 minus x, so anytime we encounter it, just leave it so that we can factor it later. We're coming back over here. Well, we can only get this far over without losing our view. So y prime, using the product rule, which is u prime v. I have 3 minus x squared over 2 root x plus 1 plus v prime u. So that's -2, 3 minus x times x plus 1. The 1/2, yeah, let's just put it in the root. Square root of x plus 1. All right, well, I need a common denominator. I know I have to keep going because they want it to look like this. The common denominator is clearly 2 root x plus 1. So in the numerator, I also have to multiply by 2 root x plus 1. Let's change our zoom. We come way down here for the simplifying. So in the numerator, I now have 3 minus x squared. Expanding this 2 multiplies with this -2, and I get -4. The 3 minus x is still there, and this root x plus 1 times this root x plus 1 is just x plus 1. All over 2 root x plus 1. I have to keep going because I need it to look like they said. But I notice here I have a 3 minus x, and here I have a 3 minus x. So that's my common factor in the numerator. So I factor out a 3 minus x, which leaves like still another 3 minus x here. And in the second term, I still have this -4 and this x plus 1. So that's going to be -4x minus 4. All over 2 root x plus 1. Continuing, I have 3 minus x in the numerator. Combining my like terms, I have -5x, and 3 minus 4 is -1. All over 2 root x plus 1. Normally this would really be enough, but if you look at the way that it looks in the book, what you were asked to do, it's supposed to have in the numerator 5x plus 1 with a minus in front. So we're going to factor like this minus out of here. So it's -3 minus x. These become 5x plus 1 all over 2 root x plus 1. Let's zoom out so we can see this whole thing. It's really a very long problem. That's just part A. The whole thing was it said, find the first derivative, but keep doing all the algebra required until it looks like this. So we did it. We made it look like that. Now part B. Find the x-coordinates of all the points on the curve where the tangent is parallel to the x-axis. So like the tangent looks like this. The gradient of the tangent is the first derivative of the function. So they're asking us, when does the gradient equal 0? Sorry, when does the first derivative equal 0? Because the gradient of this type of line is 0. So for part B, we're asked to solve y prime equal to 0. Even if you couldn't figure out the derivative, it was a show that problem. I already knew that this was the first derivative, so I'd be using that to solve this. I'm going to write it down, and then we're going to zoom in on the screen. So 0 equals -3 minus x times 5x plus 1 all over 2 root x plus 1. Okay, solving something equals 0 is great because you just multiply the denominator over, and if anything times 0 is still 0. So we have -3 minus x times 5x plus 1. Two things multiplied together to be 0. One of them is 0. So either x is 3 or x is -1/5. However, we go back to the question to make sure, do they want only the x coordinates or do I also have to find the y coordinates? Reading back, it says find the x coordinates. So I'm done. This is it. The whole answer is x equals 3 and x equals -1/5.